Okay, so now I'm going to introduce you to some different types of insulation and basically how insulation works. Okay, so hopefully you know that insulation prevents heat flow. It can prevent airflow depending on the type, and we'll go over some of those in a minute. But that's not what defines it as insulation. What defines it as insulation is the fact that it helps prevent heat flow. And again, you got to be really careful to distinguish between these two. And it does this primarily through air pockets. Okay, so remember, air is a really poor conductor of heat. Okay, and so heat just doesn't really conduct through air. But it also uses those air pockets to minimize the convective and radiant flow of heat as well. And I'm going to do a quick demonstration here in a minute. Okay, so let's think of these two surfaces here. Okay, two surfaces here. Let me get my pen back. Okay, so we have two surfaces here. Here's one, and here's the other. Okay, so this one on the right has all these air pockets, it's insulation, and one on the left has none. So if you think about, if you have some warm air, let's say it's 7 degrees here, and it's whatever 10 degrees outside. So that heat, that warmth, it's going to conduct. Let's say this is just wood or anything, metal, even drywall. It's going to pretty much conduct right through there, right? Like there's not much to prevent that heat from flowing from this side over to this side. So conversely, if this is my 7 degree side, and here's my 10 degree side over here, so now I have this warm 70 degree surface, so I have warm air here, and it really wants to get over here, right? So in order to do that, it conducts through this solid piece of material, and then it hits this air gap here. So there's this air gap. And so now it radiates across, it'll convect over that little gap, and then it warms up this little piece. And then this gets warm, and then it has to radiate across, maybe convects over, and then warms up this little strand. And then radiating here, it's convecting here, right? So this like hits it, stops, warms it up, and then it's got to radiate across here, maybe a little convective loop in here, whatever. But there's all these little, like, it hits it and warms it up, and then it has to radiate and convect, and then it has to do it again and again. So all these air pockets, there's a lot preventing it from conducting, convecting, and radiating from this side over to this side, right? So from here over to here, it's a really difficult path. Whereas here, I mean, it can just go bam, heat that up, and it's going to warm, and the heat's going to go through there pretty easily. Okay, so those air pockets are the key to insulation. So if you think about any type of insulation, whether it's a fiberglass bat here, full of air pockets, blown in cellulose or blown in fiberglass, bunch of air pockets. Foam has air pockets. Styrofoam, right, like a styrofoam cup, that has air pockets. That's what makes it so insulating. If you think about an insulated coffee mug, like a to-go mug, there's an air gap between the interior and the exterior, right? There's a little gap. Well, that's your air pocket, right? So that's insulation. So that's pretty much how insulation works, okay? And there was a video that does a really good job of illustrating that. Okay, so let's go over some insulation types. Top left here, we have some fiberglass bats. So fiberglass bats are pretty cheap. You can get them at any hardware store. Really easy to install on your own. Terrible air barrier, right? They're loose. You can get them with facing on them. That does help prevent some airflow, but they're more for moisture flow prevention. So you're going to get about R3 to R4 per inch of that. Okay, really cheap, so pretty easy to use. Then on the bottom left, we have loose fill insulation. That's about the same, R3 to R4. Again, it's pretty inexpensive. It's not a good air barrier, just like your fiberglass bat. That requires some machinery to install. Like, you can't just go buy a bunch of that and then shred it up and throw it on there. You actually have to have the machine to install it, and that's what this is, a big hose that you sort of fill it in. And there's a video that I posted in this week's lesson that shows you how to install loose fill. So that's loose fill. And then you can actually use the same type of loose fill insulation, but with a different apparatus, and that's shown right here. And this is something called dense packing. So this is something, again, I posted a video this week to show you how dense packing works. But here you actually pack really densely in between the stud bays. So this is for wall insulation, and this is a good way to sort of get some insulation inside of walls. And it does actually end up, because you pack it really tightly, it ends up being a pretty good air barrier, also a good sound barrier, and it's about R3 per inch as well. Okay. Now there's some other types of insulation that you commonly see. The top left, we have Polyisocyanurate. This is one of the highest R values per inch. So this is about R7 per inch. So it's a really good insulator. You can buy this at any hardware store. A little more expensive. The polyiso itself is the stuff in the middle. It is not water resistant. Okay, so it will absorb water, so that's not good. It usually comes with a foil facing to hold it together. So it's good for dry areas. You can use on an exterior sheathing that's not going to get wet. So it's really good, R value, the highest out of all of them we're going to look at, but it's not good for wet areas. Then we have on the bottom left, we have Vermiculite. This is an old way to insulate houses. This is actually a rock, believe it or not, that they heat up and it sort of like puffs up, almost like popcorn in a way. So you can see a quarter here for a scale. So this is only in older buildings. It has good insulating value, okay, but the problem with vermiculite in the U.S., if you see a house with vermiculite, you have to assume that it has contaminated with asbestos because of where it was mined, and basically there's this mine up in Montana where they got all the vermiculite from, and it turned out it was contaminated with asbestos. So that's something, if you have, you have to call somebody to get it removed by a professional. Okay, top right we have our extruded polystyrene. Okay, this blue board, pink board, they're the same thing. There's different companies. Pretty good insulator. Okay, R5 per inch. You notice that's a little less than the polyiso. This is very water resistant, so you'll see this a lot of times in basements. You'll see this. This is really handy stuff, really useful. Again, you can get this in any hardware stores. It's not super duper cheap, but it's not super expensive either. So it's really good for below grade. So you see this a lot of times in basements. You could use this up in attics. You can use this pretty much anywhere. It's a really good stuff. And then you have your expanded polystyrene, or EPS. So this is XPS, extruded. Expanded is EPS. It's basically styrofoam. Not a good vapor barrier. It does absorb water, but it's really, really, really cheap. We don't use it that much as a retrofit, but it is used in structural insulated panels. Then we have our spray foams, two-part spray foam. This is a really good one. There's a video. This is actually in a couple videos, I believe. So this is actually two different chemicals that separately they're in liquid, and when you mix them together, they after a minute or two they form a really good foam. So this is R4 to R6. We'll say good air barrier. You can use this anywhere because you can basically spray it, and then you spray it. You spray it on, and then it's kind of wet, and then it fills out and turns into this foam. Basically, it's really great. Good air barrier. It's adhesive, so you can spray it upside down, and it's going to stick to the ceiling. It'll seal up all of these framing members as well. So it looks like this is probably a subfloor that someone insulates. That's he or she is on the unconditioned side. So it's good. It's fairly expensive, and you can see you do need some safety equipment to install it. But high efficiency buildings will oftentimes use this in walls and attic spaces as well, right? So something like this, if you're doing a finished attic and you don't have that much room because there's only 5.5 inches here for your rafters, spray foam is a really good option because it does create a really good air barrier, and it's really good, R value per inch. And so it really does a good job because it seals and insulates. But again, it's something that's a little more expensive than most of the other types, and you do need to have some training in order to install it. Okay, so that's an overview of the types of insulation. So how do you know if you need insulation? Well, the Department of Energy, the U.S. Department of Energy publishes these values. This is a map that's pretty well known. Breaks the U.S. down into climate zones, and you can see where we are in Delaware. We are yellow, and so we are in zone 4. Okay, so what this says, if we have an uninsulated attic, we should add R38 to R60. They generally recommend R48 is the minimum. If you already have, so a lot of attics, if you go into a lot of attics here on the East Coast, you'll see that they'll have, because they'll have the 2x4s for their joists, or 2x6s, and so if that's the case, you want to add an additional R38, and then the floor should be R25 to R30, so that's like underneath a subfloor. Again, this has to be the thermal envelope. Like, you don't care about the, between the first and second floor if they're both heated and cooled. But if you have unconditioned, it should be R25 to R30. So that's your ceiling and floor insulation. Now the wall insulation, if it's uninsulated, that's where you want to do that dense pack, right? So drill holes in the sheathing and blow it in. That's your dense pack insulation. If it's already insulated, you can actually add R5 insulated sheathing. So they make this, and book described a few of these, but you can add insulation on the outside of the building. You can basically put, it's basically like a layer of insulation, layer foam all the way around, and then you put the siding on top. And that's a really good way to prevent thermal bridging and maximize your insulation, because you're limited. If you have 2x4 walls, which almost all modern construction is, you're limited to 3.5 inches in your wall, and that's only going to give you about R10, 10.5, and that's not enough. You can see in the wall, in the wall you want to add more insulation than that. R10.5 is really not very good insulation. Okay, so that's hopefully you have a sense of some of the different types of insulation, how insulation works, and then how you know if you need to install insulation or not.